9.7 Common and natural logs and chains of base. We're going to start with the concept of what common logarithms is. A common logarithm basically means if you see the notation log x, it basically means that it's log base 10 of x, and that the base of 10 is going to be implied. Now, most calculators have that same sort of programming. If you see the log button on your calculator, it means log base 10. Now, just to do a quick little calculator check of how yours works, pause the video and take it out. And I believe for most of you, when you do your calculations in your calculator for log base 10, you're going to hit the log key. And let's say we're doing log of 7. You're going to hit the log key followed by the 7, and then you're going to hit enter. What you should get is approximately 0.8451. Now, if that didn't work, try pressing 7, then log. Now, knowing that if we just see the notation log, and meaning that it's log base 10, what we're going to do is we're going to find the exact values. And you do this basically what we've been doing in the last few sections. What we're going to do is we're going to set it equal to x. We're going to change it into an exponential equation. So, since 10 is the base, we're going to fill that in. So it's going to be 10 to the power x equals 1,000. What we're then going to do is we're going to change the 1,000 into something with a base of 10, which would be 10 to the third. Knowing that the bases are the same now, log of 1,000 evaluates to 3, since x equals 3 in this case. Go ahead, pause the video, and see if you can come up with 2, 3, and 4. In example number 2 with the base of 10, what would happen with this one? It would become 10 to the x equals 1 over 10,000. What we're going to do is we're going to change the 10,000 into 10 to the fourth. And to get it out of the denominator, we're going to change it to 10 to the negative 4. So in this case, log of 1 over 10,000 would evaluate to negative 4. Number 3 would be 10 to the x power equals 1,000,000. 1,000,000 evaluates to 10 to the 6. So log of 1,000,000 equals 6. As you can see right here, we took log base of cube root of 10 and we change it to 10 to the x equals cube root of 10. Change that to an exponent of a 1/3, so it evaluates to 1/3. We can also use this to get an approximation of a value. Again, by changing it into an exponent, we can change this to 10 to the 1.2 power, and that will evaluate to x, and we can actually solve for that argument in that log. So if I put that in our calculators, 10 to the 1.2 power, that would be approximately 15.8489. One way in which logarithms are used is to find the magnitude of earthquakes on the Richter scale. So if we want to find an earthquake's magnitude using the Richter scale, if the recording station measures an amplitude of 300 micrometers and 2.5 seconds between waves with B equals 2.5, what we can do is we can actually use this equation right here for the Richter to actually calculate what the magnitude is. So we can just go ahead and fill that in. We're going to figure out what the Richter is. And so it's going to be log. A is going to be your amplitude, which is 300. And T will be 2.5 seconds. And then B is given to us with the example of 2.5. We can go ahead and evaluate this. 300 divided by 2.5 is 120. And then because it's a base of 10, what we can do is we can actually plug it into our calculator. And that's going to approximate to 2.1 plus 2.5. So in this case, on the Richter scale, this would be approximately a 4.6.